So as we have introduced Mr. Narang already, he will talk about large-scale induction of renewable power into grid and power quality. So let's welcome Mr. Narang.
Today's topic, you are having enhancing power plant performance. And I would be talking mainly about the renewable induction into the grid. The large-scale induction of renewable energy, renewable, you can say, generation into the grid, and the challenges which it has brought, and the issues, whatever we are facing, and what are the solutions, and what has been done so far, and how it started. I'll discuss maybe chronologically how it happened in India so far. What we have is we have a very ambitious target, very challenging target, and it is that we have to triple our renewable generation by 2030. Now it is around 179 gigawatt, and we have to make it around 500 gigawatt by 2030. And initially, when we started, we had the plants coming up, and there were norms available for the support. Mainly what we need is a reactive power support when we add these plants into the system, into the grid. And all the utilities had the norms to have maybe 20% or 30% as per their convenience or their understanding. The renewable plants were supposed to have that much of in-house internal reactive power support available, but it was not being enforced. So initially the things started, the renewable energy was added to the grid without any reactive power support. And then what happened is we saw large scale trippings, particularly in remote areas. More or less, all these renewable plants, they are coming in remote areas only. And where the short circuit ratio is very poor, the grid inertia is very poor, and the fault, whenever it comes, we have large scale isolation of the renewable energy. And this happened in 2022. We had almost 28 or so isolations. More than 1,000 megawatt was lost during these instances of maybe fault, followed by the isolation of these systems. And the reasons were multiple, but what was mainly thought was that reactive power support is missing, and CA had mandated that we should have now 33% reactive power support whenever a new RE plant is coming. And initially this was implemented by way of switched capacitor banks. And when these trippings occurred in Rajasthan particularly, it was found that maybe this support available in the form of switched capacitor banks is not adequate. What is needed is a dynamic reactive power support to go through these LVRT situations, to overcome these situations when the fault is there and there is a voltage dip, and we have to restore the voltage. We need the reactive power instantly. And switched capacitor banks are of no use. They work only in steady state conditions. So they mandated now that instead of switched capacitor banks, the 100% support will be dynamic reactive power support in the form of STATCOMs. So that was done. But again, that also was not the only problem, because in these areas, as I said, the SCR is poor, the grid inertia is not there, the fault, whenever it occurs, it is not cleared in time. And what goes is the inverters go into oscillation mode. And even if we have the STATCOM available, it is not going to help out. So what is required is we have to work on many fronts. One is that we have to have the dynamic support. That is, there is no doubt about that. We need dynamic support. The capacitor banks, the switched capacitor banks may not be adequate. So along with that, what is required is that we have to have to maintain the grid stability. We have to see that our inertia has to be maintained. So whenever these new plants are coming, now what is happening is there is an awareness, and the more and more plants are coming along with the grid forming inverters. Earlier, we used to have only grid following inverters where the inertia is poor. And in the main conventional plants, we have the synchronous condensers, which are there to maintain the grid inertia, and they are able to feed the fault also. And before you can say the system collapses, it is restored through the maybe LBRT STATCOMs and whatever we have the systems available, reactive power supports. So we have to work on many fronts that the stability has to be maintained, and for that we have to see that we don't continue with the conventional renewable plants without any grid forming inverters. Means the battery energy storage systems have to be there coupled with the renewable plants. Then only the things can be taken forward. So these initial problems, the teaching problems we have seen, and maybe we are also learning along the process only. And as and when we are facing the problems, the things are being mandated. The CA is very proactive. They did that, you can say, reactive power support through STATCOMs. So that was one of the, you can say, measures which was taken to see that we have the grid stability when we are adding these large scale renewable plants. Then power, along with that, it is not only that we have to have this, as I said, 2-3 things: the inertia, the SCR ratio, whatever best we can have, that we cannot change overnight in the remote locations. And the inverter selection is also very important. So we have been having assortment of inverters without any maybe proper background checking and things like that. Whereas the other countries, they have very stringent norms to allow the inverters, what particular makes of inverters in the grid. So that is that we have to have a proper inverter selection, we have to have proper inverter tuning, and we have to have system modeling. All these things are being now mandated by CA. So what is happening is the inverter tuning is done, the system modeling is there, and we have to have this PSCAD, we have to have PSSE, and we have to simulate the conditions on the, you can say, software, and then we have to run the plants, and we have to see that these things work. So all these things maybe have been gradually introduced, and we are maybe on the right track, and we will be able to maybe ride through these situations, because these large-scale induction, it has its own problems, it has its own challenges, and we have to see that we are able to move along with the solutions. And reactive power support, it is not only required for the renewable plants, within the renewable plants. What is required is the reactive power support has to be available throughout the power system. It has to be available at all the voltage levels. All the voltage levels have to be self-sufficient in the reactive power support. They should not be depending on each other, because that will again create a problem. So all these things we have to see that when we move towards this net zero, when we move towards the renewable, because the transition has to be smooth, and to make this transition smooth, we have to see that we, as and when we face the problem, because we are not the first people to do these things. Already people have done it. There are examples available. There are norms available overseas. We have to see that we are not lagging behind these things. And as and when the we are going forward, we should go forward along with the solutions. Whatever is required, it should be mandated, and it is already done so far. And we should move in that way. The other issue I wanted to discuss was about the power quality. Reactive power support is one of the major requirements, because without that, there cannot be a stability in the grid. But power quality issue is something which has come now, along with the renewable induction. Earlier, we used to have conventional plants. The conventional systems, whether it is transmission, it is distribution, or it is generation, all these processes are very clean. There are no harmonics, there are no power quality issues, mainly related to harmonics. But now, as we are going towards maybe close to 100% renewables, the renewable plants have issues of harmonic generation. And it is not only the simple harmonics, because normal harmonics, what we have been dealing with through the loads, whatever loads we have they generate some harmonics, and they are normally a lower order harmonics, and we have conventional solutions. We have active filters, we have passive filters, and they are easy to handle and easy to tackle. We have been able to manage those, you can say, harmonics, power quality issues. But what is required is in the renewable plants, the solar plants, the wind plants, the harmonics are not only the lower order. Along with the lower order, we have higher order harmonics. Up to, say, maybe 49th harmonic we have seen. Actual measurements as well as through the simulations we have seen, these are the harmonics available in the systems whenever the renewable plants are coming. So along with the conventional solutions, we need some special solutions, because active solutions or the passive solutions, conventional, what we have, the LC filters and the active harmonic filters, or even the STATCOMs, we can do that thing. They are able to tackle up to maybe certain order, maybe 13th or so is the best, you can say, mitigation available through these means. And for higher order harmonics, we have to have the special high pass filters. And high pass filters, so far, we don't have many of them in the field working. People have started putting it because, again, here, the CA in time has woken up. They have mandated that all these plants, the running plants as well as the incoming plants, have to have the compliance with IEEE 519 norms as far as the harmonics are concerned. So these plants now already, they are in the process. Some of the maybe high pass filters are in operation already, and more are coming. Almost every major solar plant. Now we have the grid scale solar plants. Now it's not even the gigawatt scale plants are coming these days. So the things are moving at a very fast pace, and we have to be prepared to catch up with these things. And the maybe it's not only the new system like the harmonics mitigation systems I was telling. It is something which we have not been doing so far. This is a new sort of field in India. Maybe few people have done it earlier, but on large scale, on the mass scale, it has started now only. And it's not a very big thing. It is easier because as we go along, we'll be able to solve this problem also. And the other issues means to enhance the performance, we have to see all this. I talked about mainly reactive power and the power quality. These are the two issues we have to see, that we take care of these issues so that we are able to have a stable renewable power. And other normal issues like maintenance and other things, as we go along, we have to manage that also. And the other thing is the STATCOMs, which I talked, which is made mandatory. Now, all these plants are connected at 33 kV level, mostly. And at 33 kV level, we have to have a STATCOM imported. And our major dependence is only on China today, because no other source is maybe commercially viable or even technically not superior to whatever we can get from China also. So the almost 100% dependence is on China for the STATCOMs. And already we have a few of them operational. And this is it may be a long process before we can develop such things in India. But as long as it is not there, we have to keep depending on the overseas supplies. And the other thing is the outgoing plants, the conventional thermal plants which are outgoing. So they are being phased out because we have to reduce our dependence on fossil fuels, and they are being phased out gradually. There, what we can do is for improving the grid inertia. Whenever we phase out these plants, the synchronous condensers which are available, they can be retained, they can be used at elsewhere at places where we can shift them and use them. So that will help in improving the grid inertia. So that is another. We have to work on all these fronts so that we have a stable renewable supply and we are able to move smoothly. The transition has to be very smooth. And the manpower also, as we go along the manpower development for the renewable sector, it is maybe a different set of capabilities are required. Now we have more and more digitalization. We have more and more, you can say, artificial intelligence, the metering and everything is now different. Even we don't need the conventional, you can say, signals for monitoring. We take from the software itself. Though all those things are new things, and it's all basically now digital. The controls, the automation, and everything. So this set of capabilities also, maybe as we go along, we have to keep on developing those things. So these are a few things which I wanted to talk about renewable, because we are moving towards 100% renewable energy, and we should be prepared for that. Maybe I might have missed out certain points, but we have to keep looking at whatever we are lacking, and we have to keep improving on these things. I think that's all for the time being. If there are any questions, I can take up and we can discuss.
Thank you, Mr. Narang.